Right, so we look at this question here. It's all very symmetrical, isn't it? Okay, because we've got the supports here, 3 centimeters either side of the center. So what I'd say then is, if there's no extra weight on this rod and all we've got is the mass of the rod, which was 6 newtons, then the reaction at P and reaction at Q will be equal, they'll be identical because it's all symmetrical. But then they say a body of weight 5 newtons is placed on the rod at a point which is distance x centimeters from the center C of the rod. Find the greatest value of x if equilibrium is maintained. So I put it over here. You could have put it over there. It doesn't matter where you put it. But I put it here so that distance from the center is x, so that equilibrium is maintained. Now if equilibrium is maintained and they want the greatest value of x, well, the further I push it along here, further chance I've got of it actually tilting, yeah? Because if I move the force outwards, it could end up tipping. If it tips or tilts, it'll tilt about Q, won't it? Okay, so it'll tilt about Q, which means for greatest x, the greatest value of x, it'll be on the point of tilting. Okay, it will be on the point of tilting about Q, about that point Q there, which means if it's on the point of tilting about Q, there'll be no sort of force upwards here because it's about to lift. So therefore RP will equal 0. Okay, the reaction at P will be 0. So no, that's good because I can take moments then, and when I take moments, that won't have any effect, right? So it'll sort of disappear. But if I take moments about Q, I don't need to worry then about working out the reaction at Q. So we work at the moments about Q, and that's the center, okay, of the center of moments. So clockwise, if that's like the center of my clock, the 5 newtons be going clockwise, won't it? Now I want the distance from here to of course Q, right? I don't want x in this sense in terms of the distance. So when I take moments about Q, I want this shorter distance here, yeah? But if you think about it, if all of this is x here, and that's 3, to get that distance, I just need to cut 3 from this x, so sort of x minus 3. Okay, so taking moments about Q, okay, I have 5 times that distance, which is x minus 3, and that will equal then the anti-clockwise, so 6 newtons will be going anti-clockwise about that point, so it'll be 6 times 3. Okay, so I'll have 5x minus 15 equals 18. So 5x then, we'll take that over, it becomes 33. So x then be 33, divide by 5. So I get my x out to be 6.6, I think. Okay, just double check that on the calculator. Yeah, 6.6. Exactly, 6.6 centimeters. Okay, that's the greatest x can be. So it's beyond the point of tilting about Q, which means the reaction of P then will be 0. So it doesn't take any effect then when you take moments.